Hi, everyone, and welcome to our webinar, How to Modernize Your Applications and Drive Business Value with Amazon Aurora. My name is Chuck Edwards, and I'm the Global Lead for AWS Database Partners, and thanks very much for your time today. So we all know that more and more business models are embracing the cloud, from SaaS applications like Salesforce to new and innovative business models like Airbnb and Netflix. The cloud is becoming a more ubiquitous part of application development and delivery. And customer adoption of the cloud has been so rapid and so strong that in 2017, as you can see from this quote here, IDC reported that all ISVs who want to stay relevant to their customers need to have some sort of cloud strategy or adopt the cloud in some way. And backing up IDC's assertion, we see additional data from Gartner. Gartner reports that 28% of spending within key enterprise IT markets will shift to the cloud by 2022, up from 19% in 2018. And they also report that by 2020, all new entrants and 80% of historical software vendors will offer subscription-based business models as well. And so what does this mean if you're an ISV? So if you're an ISV thinking about your move to the cloud, there's a few things that you can think about. At AWS, we see successful ISVs, those that are growing their business in the cloud is what I mean by successful, take a more modern approach to software development. And this is an approach to designing, building, and managing applications that enables faster innovation and increased customer responsiveness. The best practices of modern application development arose from our experience serving millions of customers and building applications for Amazon.com. And we've observed common approaches that enable our customers to increase agility and build better applications that support the success of their businesses. So why are ISVs modernizing applications on the cloud? They're rethinking their applications because the cloud lets them move faster and creates a lot more value for their customers at a lower cost. Things like pay-as-you-go pricing and on-demand infrastructure mean that ISVs don't have to pay for more than they use, which are savings that can then be passed on to their customers. They can also build in global resiliency and durability without paying expensive license fees for disaster recovery and high availability features for their software. And they can scale globally as fast or as slowly as they want without deploying hefty capital expenditures, not just for hardware, but upfront licensing costs as well, keeping innovation high and costs low for their customers. So while different ISVs approach these practices from different starting points, we do see some commonalities. One of the most common starting points is to move away from the expense and restrictions of commercial databases, which often increases customers' application cost of ownership while adding little actual business value. ISVs who can avoid these cost restrictions have an advantage when considering the global market of millions of AWS customers. Because customers still expect performance, availability, and durability, but they don't expect to purchase additional database licenses for these behaviors. Customers expect ISVs to support their own modern development practices as they move their infrastructure to the cloud. And they definitely look for flexibility and speed of deployment that's difficult or impossible to achieve on-premise. Commercial databases specifically present some fundamental challenges when considering a cloud deployment strategy. Scaling and agility is limited to hardware availability, location, and even license availability and costs. Imagine a customer deploying your software with single points of failure just because they don't want to spend additional money on database licenses. And as customers move to the cloud, on-premise database solutions often don't natively integrate, forcing customers and ISVs to build or buy the integration that they need. So we received a lot of feedback from customers and from ISVs who listen to their customer about what they really need in cloud-native database solution. They tell us that commercial databases like Oracle and SQL Server have lots of amazing features, but they come at a really high price, many times as add-ons and not included in the base product. And ultimately, these costs, whether they're used or not, must be passed through to the end customer, raising the total cost of ownership for an ISV's application without adding direct business value in many cases. As customers and ISVs alike rethink their applications for the cloud and AWS, they've made it clear to us what's important. They don't want a huge list of features that they may or may not use. They want speed of deployment, hyperscale performance, cloud integration, and they definitely don't want to pay huge upfront licensing and punitive ongoing support costs just to run their business applications in the cloud. And as we can see from this data, again from IDC, they're clearly showing us that relational database in the cloud is projected to far outpace on-premise deployments. By 2021, 34% of worldwide relational database systems will have moved to the cloud, as to 2.6% on-premise. And this is a projection, but this is definitely showing the trend as seen by IDC. So this growing trend and customer feedback is why we built Amazon Aurora, which delivers the performance of commercial grade databases with the pricing, freedom, and flexibility of open source databases. Amazon Aurora is a MySQL and Postgres compatible relational database built for the cloud that combines the performance and availability of high-end commercial databases with the simplicity and cost effectiveness of open source databases. Aurora has 5 times the performance of standard MySQL and 3 times the performance of standard Postgres with the security, availability, and reliability of commercial grade databases at 1/10 the cost. Aurora is also fully managed with repeatable operational tasks like provisioning, patching, backups, and even automatic failover to secondary sites. Finally, Aurora is an integrated cloud-native database with features like Lambda and S3 integration and serverless deployments, where the database instance computing power can grow and shrink on demand. Customer reaction to Aurora has been overwhelming, making it the fastest growing service in the history of AWS. In 2015, Aurora already had thousands of customers, including enterprises like NBC Universal, PG&E, and the United Nations. In 2016, the number of customers grew by 3.5 times, with household names like Netflix, LexisNexis, and Ticketmaster joining the list. And in 2017, the number of customers grew by 2.5 times, with organizations like Expedia, NASDAQ, Verizon, CBS Interactive, Dow Jones, and Hulu running their business critical workloads on Aurora. Today, we have tens of thousands of enterprises and startups running their applications on Aurora. Using Amazon Aurora as a foundation for ISV software provides a number of strategic benefits. First, AWS has millions of customers, and they consistently choose solutions that do not require purchase and maintenance of commercial databases. Second, removing the cost of commercial database license can reduce customer TCO for ISV software, regardless of a SaaS or single tenant deployment model. Third, eliminating these heavy upfront costs from ISVs and their customers, embracing the pay-as-you-go resourcing model opens the door for more flexibility in deployment and pricing options that customers expect in the cloud. And finally, Aurora's native integration with other AWS services opens the door for innovation that really matters to ISV customers, including AWS Analytics, artificial intelligence, and machine learning services. And it's not just cloud-native startups embracing Aurora. Many familiar ISVs like BMC and Infor offer Aurora-based or Aurora-compatible versions of their software. So to help the growing community of ISVs who are modernizing their offerings with Amazon Aurora, in 2018, AWS launched the Database Ready program. Database Ready provides the people, tools, and support that ISVs have asked for to help them deliver a cloud-native Amazon Aurora-based offering to their customers. The program mission is to help ISVs build profitable cloud-native solutions faster with Amazon Aurora. The program provides some standard benefits. While building, ISVs have access to technical support from both AWS and our Database Ready system integrator partners, as well as service credits to help offset development costs. When an application is ready for customers, we'll feature on the Database Ready webpage, and we also may make it ready for launch through AWS Marketplace if that makes sense for the ISV. Finally, Database Ready can help accelerate net new and legacy customer adoption of your Aurora platform through marketing development funds and go-to-market promotion and support. Taking a closer look at some of our Aurora-enabled ISVs, Alfresco found they could scale 10 times on Aurora MySQL over their self-managed MySQL deployments. Alfresco now scales to over 1 billion documents with a throughput of 3 billion documents per hour on their Aurora MySQL deployment. And BMC recently certified their Remedy application to run on Aurora Postgres. BMC Remedy customers who are paying thousands or tens of thousands of dollars for SQL Server or Oracle licenses can now deploy Remedy on AWS and drop those licensing costs.
Hello, everyone. My name is Steve Bartolo. I'm Vice President of Architecture Services at mLogica. Today, I'd like to talk to you about application, database, and environment modernization and moving over to AWS, and about our background and how we can help you do that. mLogica has been in the business of doing conversion, translation, and migration off of legacy platforms over to the cloud for a long time. In doing so, we've been able to build an automated tool set and a very strong, proven methodology and framework to accomplish that. If you look at the generations of how people have modernized and converted off their platforms, it's really been 3 generations, at least for us. In the first generation, there was very manually intensive approach. Okay, there was a lot of manual rewrites. It was resource heavy. There were long deployment cycles. And as a result, there was a lot of costs. In generation 2.0, we started building in and writing our own automation tools to start helping the process. And we saw a significant improvement in our abilities to do migrations and to do 3 things: accelerate timelines, reduce the risk, and as a result, reduce the costs. Where we are today with generation 3 is that we are very highly automated. We are able to have built our tool sets up to accomplish almost 100% translation and be able to reduce the time to market and to get these projects to where they need to be in a really acceptable time frame. So what are the 4 basic tenets of how we approach our projects? The tenet number 1 is transparency. We are very open and work collaboratively with our AWS teammates as well as our customers. We communicate through the process, and everybody at the end of the day understands what they're getting, when they're getting it, and how much it's going to cost to get them there. We build our frameworks and our deployment frameworks with the AWS team. We communicate our target architectures to our customer. We align them to the requirements from a business and functional standpoint to make sure that everybody's in agreement. Our approach is highly automated. It's based upon the tool set that I just discussed on the previous slide, where we're able to gain a high degree of automation, but our tool sets are also enhanced with machine learning. We learn the different patterns of how people write code, especially around SQL, around their interfaces, because not everybody does things the same. So instead of always having to make manual adjustments, we have our tool make a lot of the adjustments themselves so that we take into consideration those learned patterns for our next engagements. The last tenet is customer migration and support. Let's face it, as you go and migrate and convert off of one platform to the next, it's about being able to operate, maintain that platform, and maintain the integrity of the platform. Just like with any well-derived architecture, if you can't operate your platform, it will crash, it will break, and you will have very unhappy customers at the end of the day. So our approach is twofold. First, we always offer post-migration support to be able to support our customers and do 2 things. A, teach them how to fish so that they can be successful in supporting the environment themselves. Or if they're not interested in doing that, we'll offer them a managed services program where mLogica will be responsible for supporting and operating that environment themselves. So how does automation fit in to what AWS has? Well, if you really look at it, there's a lot of commercially available databases, ISV platforms out there that are ripe candidates for migration and conversion onto the cloud and onto Aurora. So our mLogica Database Migration Studio with our automated code translation plugs in nicely with the variety of tools that AWS has on the table and has to offer. So it really becomes a quick, highly automated approach that drives the 3 basic things that I'll talk throughout this presentation on, and that is the acceleration of time, the reduction of risk, and of course, the reduction of cost. The translation and conversion approach also takes into consideration the basic best practices of security, identity management, and any of the compliance tools that you have to have in your environment as well. So the framework and methodology that we've put together is basically 6 basic areas. The first is evaluation. It is understanding what's in your environment. When mLogica looks at an environment that is a candidate for migration, we look at it as an IT ecosystem. What does that mean? Well, databases don't operate in a vacuum. Applications don't operate in a vacuum. It all has to operate together. So what we look at are upstream and downstream application dependencies and the interfaces that plug in there. We look at ETL, data transformation, reporting, and operational tools and compliance tools. So we understand and gain the big picture of what's going on in the environment. We then go through to the second step, which is analysis of all of the objects within those environments that have to be translated and converted in order for things to work. We then go to the translation phase, or what we'll refer to as the porting phase, where we'll start putting all of the objects and all of the things for conversion through our tool set. I'm going to talk a little bit about the next step in combination with the translation step because we view that these things go together. So if you view this as an iterative cycle, we take a first pass at translating the objects and converting the objects for various reasons, because people don't write code the same. We may not have seen this pattern in the past. We may not have been able to learn the pattern. We'll take and we'll figure out why things didn't convert in the first step, understand those, code them back into our tool set. So on the second pass, we get a much higher translation rate. And by the third pass, between the machine learning, between manual adjustments, everything goes through in an automated fashion. Why is that important? Well, some of the larger environments that we've migrated in the past have had upwards of 15 to 20 million lines of code. Even when you look at 1% of that, that's a lot to have to rewrite. That's a lot to have to manually adjust, and we don't want that because it introduces risk. So that's why our tool learns, we adjust it, and we get 100% pass through at the end of the day. Now, there are those things that functions or whatever may not convert, and we'll work with our customers to understand what they need those functions for, look at the business logic, and make any manual adjustments. But those are, what I'll consider when I say manual adjustments, manual rewrites. But we'll figure out what they're for, what we can replace them with, even if they're still needed, and it only becomes down to a few things. So once we have all of the code converted, then what we do is we go through unit testing to make sure that those translated objects compile, they link, and that they return the functionality that they're expected to. We then move them into a system integration test environment where we start working with the customer. If they have test regression or regression test suites available, if not, we'll help them write those, and we can include that as part of the project to take them through the testing phase. And then we'll test it, make sure everything meets the requirements, and we'll deploy it. Deployment can get a little interesting because we've had customers that have gone into production after a week. Some customers have left parallel environments, meaning their newly converted environments and their old legacy environments in parallel for upwards of a year before they get comfortable to say, let's just flip the switch. But at the end of the deployment phase, they flip the switch, and then we go into post-production support. And I've talked a little bit about post-production support, where we can provide on-site staff to help them operate the environment, learn the paradigm changes of the environment, to be able to teach them how to fish within their new environment so that it is rock solid operational at the end of the day. And if they don't have an interest in wanting to do operations and they've made decisions to get out of the data center business altogether or data center operations altogether, we're more than happy to apply our managed services program to help them accomplish that. So I've talked a lot about automation, okay? Why is automation so important? Well, we've seen a variety of customers, and the slide that you're looking at here is industry standards, right? This is what we've seen across the industry. People who've decided to take on projects themselves, by statistics, fail 50% of the time. When you look at what's behind that failure, it is High risk, it's manual rewrites, it's a bunch of resources that have spent a bunch of time because they don't have the right tool sets or the methodology to accomplish their migrations. 50% represents an awful lot of wasted dollars that they could have either recycled into their environment for innovation or put towards an automated approach. By industry standards, automated approaches really only fail about 2% of the time. However, with mLogica, I'd like to tout that we've had 0 failures in our approach because of our rock solid tools and our methodology that we deploy with our customers. However, statistically speaking, automated is the way to go. So, how does automation impact on resource utilization? Well, there's a lot to do in these migrations. If you break it up into 4 major phases, in the analysis, the collection of data, we can reduce that effort through our automated tool sets by 50% because we're able to get rid of the manually intensive labor where people have to go out into the application and database environment and collect all of that information to then plug in and go through the porting or the translation phase. Our automated tool set between porting and migration and hardening reduces that effort significantly. It reduces the manual effort by 90% through the port phase and 75% through the migration hardening. When we get into testing and UAT, our tools allow us to reduce the manual efforts by 50%. So when you look at manual effort reduction, that translates into an accelerated timeline, a reduction of risk because you get rid of the manual intervention, and it, of course, significantly lowers the price point and the cost to deploy these projects. I'd like to go through a couple of examples of folks that we've had the ability to work with. From a credit card company who was looking at different ways to convert their environments, the efforts that they were coming up with basically were at least a 38-month project. They were looking at doing it themselves. They were looking at maybe using some off-the-shelf tools that they really didn't understand, and they didn't have a methodology to deploy it. We were able to come in, do the evaluation of the environment, and deliver them a proposal that took their 38-month timeline down to about a 10-month timeline at a significant reduction of cost. The second example was a trading company where they were just going to do manual rewrites. They weren't even looking at off-the-shelf tools. They were scoping it as a 20-month project. Again, we came in, understood the environment, and were able to lower it down to a 6-month effort. A telecom company that had a large legacy platform that they wanted to do a conversion/migration of was scoping it at 36 months, and even then, they were being a little bit naive in what it was going to take the manual approach. We were able to come in with our methodology and really lower that down to about a 7 to 8 month effort. So when you look at it, it is an acceleration of the timeline. It is a reduction of the cost, and it's a reduction of the risk, and it significantly enhanced these 3 entities' ability to go to the board to get the money to do the projects because they were able to see a win much sooner in the process, and it was a much more stable and solid approach. So let me talk a little bit about TicketSocket, which is one of our customers that had data siloed across multiple data centers. They were using multiple database servers and cloud providers, which resulted in massive inefficiencies and a lack of visibility into their data. Our solution was we brought them to AWS. We converted their databases to Amazon Aurora, and we were able to use the native tools within the environment to significantly reduce the complexity in their environment. The results of that were that we were able to drive out cost, right, in their environment, which made them very happy. We were able to achieve efficiencies so that people could use this application in this environment in a stable, predictable, solid way and be able to return the results that they needed quickly. And we were actually able to accelerate DevOps where they're able to build better feature enhancements in a quicker, more reliable way, as well as we were able to tighten up security and deliver greater functionality to the customers. So with that said, when you download this webinar deck, you're going to get information about an 80-hour assessment that we'd like to offer out to you to come in and assess the environments and understand what's out there. And if you're interested, please contact myself, Steve Bartolo, Vice President of Architecture Services at mLogica. My contact information is steve.bartolo@mlogica.com. Or you can contact my counterpart, Peter Burney, who's the Vice President of Business Development at peter.burney@mlogica.com. Regardless, thank you very much for your time. I hope you found this useful, and we're looking forward to doing business with you.